Assalamualaikum and hello everyone. My name is Munawwarah and today I'm going to talk about MOSFET. But before we begin, I'm going to walk through you guys about the content of this video. First, we're gonna look into the introduction of MOSFET, the working principle, the characteristics, applications, and also the comparison between other transistors. In electronics, a device that is used either to amplify or act as a switch for electronical signals is known as a transistor. Invented back in 1959 by Muhammad Attallah and Dawon Kang, metal oxide semiconductor field effect transistor, or simply known as MOSFET, is one of the most commonly used transistors in electronic application. MOSFET is a device that is made up of three terminals, namely the source, drain, and also gate. Before we get into the working principle of a MOSFET, let us look at the type of MOSFET that is available. MOSFET has two operating modes, which is the enhancement mode and depletion mode. Both the enhancement and depletion mode comes in either P or N channel. The major difference between these two modes is the presence of a channel. In enhancement mode, source and drain are separated by a substrate and current is only conducted when channel is formed between the two terminals. Hence, the channel is said to be enhanced. In depletion mode, there is a pre-existing channel between the source and drain, but will be depleted during operations. Now let's get into the working principle of a MOSFET. For simplicity, we'll only look at the enhancement mode of MOSFET, particularly the N channel. P-doped semiconductor, which the majority carrier are the holes in green, is used as substrate, while N-doped semiconductor, where electrons in red are the majority carrier, is used at the source and drain terminal. An insulation layer that is made up of metal oxide is placed in between the substrate and the gate terminal to create a static field that is caused by the difference in potential. In MOSFET, we want to be able to control the current that passes through from source to drain. Initially, current cannot be conducted since there are no physical connection between the two sides of N region, and that is why enhancement MOSFET is said to be normally in its off stage. When positive voltage is applied at the gate terminal, majority of the holes in P substrate is repelled away while the minority electrons is attracted to the gate. This causes the region to be less positive and more negative due to the presence of excess electrons. A process called inversion happens where P-type semiconductor changes to N-type. Hence, a conductive channel is formed connecting the previously separated N regions, which now allows electrons to move between the two terminals. If more voltage is applied to the gate terminal, stronger electric field is present. Hence, more electrons will be attracted to the gate, resulting in a wider channel that allows more current to flow. The characteristics of MOSFET is divided into two parts. The first one is the drain characteristics, while the second one is the transfer characteristics. The drain characteristics can be obtained through the plotted graph of IDS versus VDS. From the graph, we observe that there will be no current flowing in the device until VGS exceeds the threshold voltage. These states account for the cutoff region of enhancement MOSFET. After VGS surpasses the threshold, IDS increases as VDS increases according to Ohm's law. At certain points that is determined by certain value of gate to source voltage, IDS will stop increasing and become constant, which means the current now has become saturated. The locus of pinch-off voltage is also observed between the ohmic and the saturation region. The transfer characteristics explains that changes in both value of IDS and VGS will affect VDS. Next, we move on to its application. MOSFET is used as a switch in electronic circuit. From the drain characteristics that we observe, we now know that when VGS is lesser than the threshold voltage, the device is said to be in its cutoff state and no current flows within. Thus, it acts like an open switch. When VGS exceeds the threshold voltage, current is able to flow from the source to drain and is now acting like a closed switch. Also, we observe that a small change in VGS will result in higher change of IDS, thus amplifying the current. Lastly, we look at the comparison between MOSFET and other transistors. FET and MOSFET have similarities in terms of having unipolar current, source, drain, and gate as the device terminals and being a voltage-controlled device, while bipolar junction transistor or BJT differs by having bipolar current, base emitter and collector as the terminals, and a current control device. Though BJT has no mode of operation, FET only operates in depletion mode and MOSFET operates in both depletion and enhancement mode.